Alright guys, so what we're going to talk about now is this I can statement of I can graph linear equations from slope-intercept form, x and y intercepts, and a table of values. So I can graph linear equations from, alright, so we'll look at each of these three ways of graphing linear equations. Ooh, fancy. Okay, let's start. So we'll first look at slope-intercept form. So we're given slope-intercept form. This might look a little weird just because of the formatting, okay, but it's y equals negative 2/3. Oh, and for some reason the x didn't show up. X plus 7. Okay, so to graph this linear equation, okay, we need to remember what slope-intercept form gives us. It gives us an intercept, the y-intercept, and it gives us slope. Okay? Alright, that's why it's called slope-intercept form. So first what we do is we graph our y-intercept. That way we have a starting point. So our y-intercept is a positive 7, so we'll go up 7, so 2, 4, 6, 7. Okay, so we have that point for our graph, and then we use our slope. Okay, if our slope is negative 2/3, this is negative 2/3. Okay, slope is rise over run. Okay, I'm sorry, my writing in here is so bad. Slope is rise over run, so our rise is negative 2, so that means we go down 2, and our run is 3, so over 3. So down 2 over 3 to get more points. So from our starting point, we go down 2 over 3, get a point. And from this point, we can go down 2 over 3, get a point. Down 2 over 3, get a point. Down 2 over 3, get a point. All right, so we've got this right side pretty good, but the line goes to the left as well. So to do it to the left, we just do the opposite. So instead of going down 2 over 3, we'll go up 2, back 3. Up 2, back 3, and that's pretty good. Using a straight edge, okay, and all I have on here is this. You then connect all of your points. So that's pretty good. And make sure at the end of your line, oh, why is it doing this? You put arrows. Oh, it's not letting me draw anymore. Throw with a free hand. Okay, I think I got it now. Alright, so that's how you, from y-intercept form, you would graph equation. Now we're talking about finding x and y-intercepts. Disregard this table over here. We don't care about that right now. Alright, so the x-intercept is where your graph crosses the x-axis. Okay, so if we look at the x-axis, it's this horizontal here. Our y value at every point on this line is 0. Okay, so for the x-intercept, y is 0. Same idea with our y-intercept. Okay, if we look at our y-intercept is where our graph crosses the y-axis. If you look at every point on here, our x value is 0. So for our y-intercept, x equals 0. So with that information, what we do is we look at our equation that we're given, 3x minus 5y equals 10. So to find our x-intercept, we put 0 in for y. So now we have 3x minus 5 times 0 equals 10. Okay, well, 5 times 0 is 0. And then when we subtract 0, we're not really doing anything. So we just have 3x equals 10. So to find what x is, divide by 3, divide by 3. 3's cancel. We got x equals 10 divided by 3, which is 3 and 1/3. So that is our x-intercept. Not a very nice number, okay? So we'll guesstimate on here. So that's our x-intercept. So we go on the x-axis, find that number, put a point there. Okay, find our y-intercept. We will put x equal to 0. Okay, so we have 3 times 0 minus 5y equals 10. 3 times 0 is 0. So really what we have is 0 minus 5y, which is negative 5y equals 10. To find y, divide by negative 5 on both sides. Those will cancel. We're left with y equals 10 divided by negative 5 is negative 2. So our y-intercept is negative 2. Alright. And now we can draw the line for these 2 points. And then make sure that you put your arrows. Okay? And that is our graph. Notice how with this, we can't really extend it out very much. If both our x and our y intercepts, let's say that amazingly our y-intercept is at a nice intersection, a nice whole number, okay, and so is our x. What we can do to get some more points in between and to the left and to the right is we can find the slope between these 2 points, okay, how those 2 points differ. So our slope would be, our rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. Our run is 1, 2, 3, 4, 5, 6. Okay, so our slope would be 9 over 6. Well, that reduces to 3 over 2. All right, so our rise is 3, our run is 2. So what we could do to find points in between here, start at this point and go up 3 over 2. And I can go up 3 over 2, up 3 over 2, and there's that point, up 3 over 2. All right, notice how I'm filling this in now. So backwards, down 3, back 2, down 3, back 2, down 3, back 2. And now I've got a nicer line. I got a full thing. But that really is only going to work. Oh, I thought I had a straight line going there. Maybe not. All right, that's really only going to work if our x and y intercepts are both on a really nice number. Otherwise, it's going to be a little bit too tricky at this point to do that. So that is graphing from x and y intercepts, and now we'll look at a table of values. So with the table of values, what we're going to do is we're going to fill out this table. So to fill out this table, we can pick a value for x or for y. Let's pick 1 for x. So picking 1 for x, I'm going to take this equation and replace x with 1, and then solve for y to get my y value. 6 times 1 is 6, so I got 6 plus 3y equals 18. Subtract 6, we're solving for y. I got 3y equals 12. Divide by 3, cancel, I got y equals 4. So if x is 1, y is 4. Alright, now I can pick another value for x or y. Maybe I can do 0 for x. That should be pretty nice. I'll make sure you're always picking nice numbers. Okay, don't be picking crazy decimals to put in there. Alright, because it can get really confusing. So I put 0 in for x. I have this equation that I'm solving for y. 6 times 0 is 0, so really I have negative 3y equals 18. Divide by negative 3. Doesn't cancel. I got y equals negative 6. Alright, look at my y's. These two numbers are kind of far apart. So I'm going to pick a number between negative 6 and 4. I'll pick 0 for y. Alright, so now I'm plugging in a value for y. Okay, not too hard with this equation that we have. We're kind of doing the same process. So now I still have 6x, right? I picked the value for y, so now I got to replace the y with 0. Okay, 3 times 0 is 0, so I just have 6x equals 18. Divided by 6, cancels, I got x equals 3. So that's why it's 3. So now that I've filled this out, what I really have is 3 points that I can graph. Okay, so this point, okay, what I do with the table of values, I'm getting points. I get x value for a point and a y value. So I have the point 1, 4, the point 0, negative 6, and then the point 3, 0. All right, so I'm going to put these points on my graph. So 0, -6, 2, 3, 2, 4. It's kind of hard to see these light colors on the screen. 0, 3. No. Yeah, 3, 0, 0, -6. 1, 4, 1. All right. So I apparently did something wrong. Because look at this. I'm not getting a nice looking graph at all. So far, it looks like I can make a line here. But this point here, this 1, 4, is wonky. Okay, so if you come across that, you need to stop what you're doing and realize something isn't right. So I think I need to check this. So what I'm going to, oops, that's not what I wanted. What I'm going to do is, oh no, okay, this one's not right. I need to redo that. So if I put 1 in for x, that means I have 6 plus 3y equals 18. So subtract 6, I get 3y equals 12. Okay, why would be 4? So maybe one of my other numbers is wrong. Okay, so if things aren't making sense, guys, don't just give up, okay? Because that's not going to do you any good. So I'm going to try. Oh, why does it do that? I'm sorry, guys. You can fast forward if you want, but I need to figure this out now. Okay, so now I need to check that value that I had. So if I put 0 in for x, what I have is 3y. Oh, I see. I put a minus in there before. 6 times 0 plus 3y equals 18. That's just 0, so I have 3y equals 18. Divide by 3 on both sides. I got y equals 6. So that's a positive 6. Okay, so that means on my graph here, my y-intercept is positive 6. All right, that looks like it's going to make a line now. So let's put the line in there. And then make sure you have your arrows, okay? So this is probably good that I messed up there, because if something's not making sense, don't just put it down. Ask a question, ask someone near you. If that's a test, don't ask someone near you. You can ask me though, okay? But make sure that it's making sense. If it's not making sense, we need to stop and think. All right. So that's all I have for this I can statement of graphing linear equations.